So this is all like fine and dandy as like theory, but like how does this help us in the real world? I know you were
I
talking
was
about
waiting for
like
Finian to ask this.
today's true pure math is tomorrow's applied math, but at what point are we like with the stuff you're studying? Is it transitioning into applied math? Is it purely like theoretical still? Like I doubt
Hmm.
this stuff is going to be used to like make me a coffee or something like that.
So yeah. So this is the question that I'm afraid that that I was afraid you were going to ask me, that I knew you were going to ask me, which is that I don't know personally because I am not an applied mathematician. I don't find the application to be the most interesting part of mathematics, but
And
I
that's
do
totally
know that
fair.
there are Catalan numbers are a very old sequence of numbers, and they definitely find themselves in application purposes. Like strictly what I'm looking at is mainly on a curiosity basis. Like it's kind of just like this is an interesting connection, and then you explore it further. And I do have a more specific research question that
Mm.
is specifically related, but is harder to answer. But the like a broader answer that I could probably give you is that um, particularly triangulations and these paths are very closely related to algebra and also like things like graph theory. And graph theory is very applicable. Like graph theory is used in so many ways. Um,
Yeah, I've heard you
but
talk about graph theory, and you're like, oh, graph theory, it gets used in so many things, but you never tell me. Uh,
Well,
like
yes,
what?
this is because I'm a number theorist at heart, and number theorists don't do applied math in a lot of ways,
That's
unless you're talking about cryptography.
um.
Hmm. Wait, what is graph theory
So
exactly? I should, or well, if you're gonna stay on this, Finian, you can do that.
no, no, no. I was going to ask about graph theory. So
I don't know
Um,
what it is.
what's graph theory?
cool. So graph theory is basically a graph is just anything with vertices and edges. Um, and draw you can draw edges between your vertices for any given reason. Like for instance, the kind of like classic introduction to graph theory is the Konigsberg Bridge problem. I don't know if any of y'all have heard of,
No.
but
No.
basically there is this theoretical town which I don't know if it is actually real, but it has like three mainland bodies and like an island, and there are rivers between them and bridges connecting the island and the different like chunks of mainland across these um, different waterways. And the question that was asked is like, can you walk across all of the bridges only one
Uh,
time and like end up on every single piece of land, but only
Mm,
do it once, and also end
mm,
up back where you started? And there are like various questions you can ask about it. And there turns out to be properties about like the degrees of the different vertices, like the parity of of vertices actually is what is relevant. So like if a vertex has an even degree, then you can make these kind of walkways through it, and it's a little bit denser than that. And I haven't taken graph theory in a few semesters, a couple of years at this point, so I am less familiar with it, but like that's kind of the classic problem. But you can have
Interesting.
graphs that basically a graph theory was a way to translate that problem into math in a more digestible way. And so instead of you're talking about like mainland chunk A and island B, you're talking about,
Mhm.
and then the bridges between them, you're talking about two vertices on a page and a line between them. And what are the questions you can ask about that? And what are the ways you can connect them? And
Interesting.
yeah.
So okay, because
mhm.
I've seen some things online where it's like, oh, here's this interesting shape. Can you like trace it out without like and
Yeah.
get back to the same spot without like tracing over your line?
Yeah,
Is that sort of the
exactly.
idea? Okay.
That's graph theory.
Why is it useful? That's why, because you said there's some applications. So do you know
Yeah.
like Yeah.
It's those fun little clicker games of going out
Well, they are
and
very
not
fun.
not having to cross back
Um,
over your lines. That's the whole backstory behind graph theory. They just wanted that game.
Well, when you're talking about graph theory and you're talking about questions of like, can you make this trip on a graph without like picking up your pencil? You're talking about optimization. Like, can you go from these points to these points in the most optimal way so you're not retracing your steps? Like, that's a classic application of like any field of math is optimization problems. And also, like you see optimization problems honestly most frequently in calculus. Differentiation is an optimization problem, but that's also optimization in graph theory.
That's really interesting. I had never thought of like differentiation as optimizing, but it totally makes sense.
Like Finian, when we learned optimization, it was in calculus class, right? And you would like find the derivative, set it equal to 0, and you find like you can find like the min and max of some function, right? That's like kind of the idea.
Yeah. Okay.
Yeah.
That kind of optimization.
So you've now been taking math for many, many years.
Yes. Well, I'm still an undergrad, so don't give me too much credit.
Still, you've taken math longer than we have because you're a mathematician, and while we may be engineers, we don't do like true math. What is
this is what's such an interesting conversation because I don't care about the application of any of my work, and all of the math that y'all do is so like application based.
Yeah, it's like entirely application based.